Hello guys, we are in section 2 of this particular momentum calculations, and as you listen, God bless you. Now we go to number 4. I think we stopped at number 3 in the last video. He said a 2 kg block of ice is moving on a frictionless horizontal surface at what? T equal to 0. So the mass is given as what? 2 kg is moving on the what? On a frictionless horizontal surface at T equal to 0. The block is moving to the right with a velocity of magnitude. So that means at T equal to 0, what we have there should be what? Initial velocity. Because initial velocity given to a body at T equal to what? 0. Now calculate the velocity of the block in magnitude and direction after a force of 5 Newton directed to the right have been applied for 4 seconds. So we are calculating the block in magnitude and direction after force of what? 5 Newton directed to the right have been applied for 4 seconds. So that means the force applied is what? 5 Newton. Now the time is what? Takes is what? For the force to be applied is 4 seconds. Then we are looking for final velocity because that is the velocity of the body after some time. So final velocity. So using Newton's second law, F equal to what? mv minus mu divided by t. I believe you still remember this formula. That is what we are using. Now let's substitute all the value. 5 equal to what? 2 times what? V unknown minus what? 2 times what? 3 all divided by 4. When you cross multiply, you are going to have it as what? 20 is equals to what? 2V minus 6. Collect like terms become what? 20 plus 6 is equal to 2V. So for us to make V the subject of formula, we should know that we have to divide both sides by V. Don't forget this one is what? 26 is equal to 2V. So divide both sides by 2. So this we cancel this. So V is equal to what? 13 meters per second to the right. So that will give us our what? Our velocity. And why is it to the right? Because the force is also applied to the right hand side. So that is just that. Let me clean this part so that we can move on to the next question. So the number 1 and number 4 is solved already for this section. Number 4 is solved. Let's go to number 5. So number 4 is solved. Let me clean this part. Now we can have more space for ourselves for the next question. Now number what? 5 says that a what? 0.3 what? Glider is moving to the right 0.3. That means the mass of the glider is what? 0.3 what? kg. This is kg, 0.3 kg. Please correct that. The 0.3 kg glider is moving to the right on a horizontal frictionless air track with a speed of 0.8 meter per second. So that means U is equal to what? Of the glider 0.8 meter per second. Okay. It has an head-on collision. That means let's call this one M1, U1. It has an head-on collision with a 0.2 glider. So M2, U2 is what? 0.2 kg. Then U2, let's see. Glider that is moving to the left with a speed of what? For it to be moving to the left is 2 minus 2.2 meter per second. Don't forget. To the left with what? 2.2 what? Speed of 2.2 meter per second. Say find the velocity in magnitude and direction of each glider if the collision is what? Elastic. So for the collision to be elastic, it means that M1U1 plus M2U2 should be equal to what? M1V1 plus what? M2V2. It means that the collision must be what? Must obey the law of conservation of what? Momentum, and can also obey what? The law of conservation of energy. But nevertheless, let's see what happens. 0.3 times what? 0.8 plus what? 0.2 times what? Minus 2.2 is equal to what? 0.8 v1 plus 0.2 v2. Now let's play with it now. This one will give us 0.24. Let's confirm it. Then the other one will give us about minus what? 0.44. Let's see. Let us confirm it. 0.3 for accuracy purpose. So that will give us 0.24. I'm correct. So 0.24. Then plus times minus is minus. Then 0.2 times what? 2.2 should be giving us what? 0.44. I'm also correct on that. So 0.3 v1 plus 0.2 v2. So what I want to do now is to subtract. So if you do that, you are going to be having what? Minus what? 0.2 equal to 0.3 v1 plus 0.2 v2. Now, having done that, this will be our equation 1. Let's take this one as our equation 1. Now, what I want to do for equation 2, let's use what? E, coefficient of restitution, is equal to what? Absolute of v2 minus v1 over u2 minus u1. That's what I want to use, absolute. Now, since what they said is elastic, we are going to assume in a case like this that it is perfectly what? Elastic. So in this case, since we are going to assume that it's perfectly elastic, because we are not giving E, you take it as 1. Take your E as 1. And having done that now, we what? Input our parameter for U1 and U2 into the equation. So what do we have? We are going to have it as what? E is equal to what? Absolute of what? V2 minus Z1, all divided by what? All divided by what? Minus 2.2 minus what? U1 is 0.8. So when you do that, I want to have, it implies that you now have 1 equal to what I told you. This one is already 1 equal to V2 minus Z1, all divided by what? 3. Because this one will not be 3. Minus 3, but absolute will kill the minus. So I want to have it as what? V minus V1, because minus now, is cross multiply. Let me write V1 first. Minus V1 plus V2 is equal to what? Cross multiply equal to 3. Let's call this one equation 2. Now let's solve equation 1 and 2 simultaneously. Let me substitute what? Let me make V2 sorry the formula. V2 equal to from 1 equal to what? 3 plus V1. So and let's put it into equation 1. So if you substitute it into equation 1, I would have what? Minus 0.2 equal to what? 0.3 into bracket what? You can actually use your calculator to solve the what? The solution, but let's play with it. 0.2 into bracket what? 3 plus V1. So what do I want to have now is 0.3 V1 plus what? This times this will give us 0.6 plus 0.2 V1. So 0.3 plus 0.2 V1 will give us 0.5 V1 plus 0.6 is equal to what? Minus 0.2. We see keep repeating itself there. Now let's bring this one here. What do you have now? Minus 0.8 equal to what? 0.5 V1. So therefore, V1 gives us what? Minus 0.8 divided by minus plus 0.5. If you divide both sides by 0.5, what do we have? More or less like 1.6 minus 1.6 meter per second. It shows that for minus to be reflected there, it shows that it's traveling to the left. Now, you can put it into the equation 1. So, we are going to have V2 is equal to what? 3 minus 1.6. We are going to have 1.4. For you to have positive, it means that it's going towards the right. So, our answer now will not be what? V1 is equal to 1.6 meter per second to the left. That means the velocity of the second of the first blinder. Then the V2 is what? 1.4 meter per second to the what? To the right. So this, don't forget that for inelastic collision, they must have what? Different velocity after collision. That's what we have proven there. For them to have what? Because they say we shall assume elastic. For elastic collision, rather, they will have different velocity after collision. That's what we got in for there, for that particular solution. So we are going to move to the last solution for this section 2 of momentum. And I believe that as you are watching me, you are new, maybe you are viewing me for the first time, you can just click the like button and subscribe. And if you are a returning viewer, thank you for watching this young man. Thank you for always being with us. Now let's go to the next question, which is the last part of this section that we are in. Now, this last question had to do with what? What we call application of what? Newton's third law. Although it has some little what? Second law applications. Because if we want to solve the question, we have to what? Apply what? The Newton's second law calculation. Now, what I want to do now is simply what? They say the rocket is fired in this space. It's still there, this rocket. The rocket is fired in this space where gravity is what? Negligible. If the rocket is what? Has an initial mass of what? What is the mass of the rocket? Let's take our parameter. 7,000 kilogram. And inject a gas at a relative what? Velocity of magnitude. What is velocity? Velocity is 200 meters per second. They say what? And inject what? A gas at relative velocity of magnitude. That how much gas must be injected in the what? How much gas must be injected in the first second to have an initial acceleration? So that means acceleration is what? 25 meters per second. How much gas must be injected in the first second? That means we are looking for m to over t. That means we are looking for what we call rate of mass. This is what we call rate of what? Of mass. Please take note of that. Anytime you hear how much mass what must it eject in it was in the 4 seconds to have an initial acceleration. So we are looking for rate of mass. So this is that's what is unknown to us now. Now, if you remember this formula, F is equal to what? M over T times V. Do you know the same thing as Newton's second law? M over T times V. The same thing as second law. You understand? And so the rocket thrust is what? Is F, which is MA, which is equal to what? Mass times what? Initial acceleration. So we can, this one is what we are looking for now. Don't forget. So for us to find M over T, which is unknown, I want to have multiplied by what? Don't forget that mass times what? Of the what? Of the rocket times the initial acceleration equal to the thrust. So the rate at which what? The gas ejected is what? M over T, which you are looking for, times what? A initial all over what? V. That's what I want to use to find our what? Our how much what? Much gas must be ejected in the first second. So this is what? Rate of mass. That's what they're asking for. So if you are using that formula now, let me remove this. So this one now was for mass is what? 7,000 times initial acceleration is what? Is 25 divided by what? By velocity of the what? Is 20 what? Is 200. So if you do that, this one will cancel this will cancel this. Okay, 75 times what? 25 times 7 should be 35, carry 3. Then 3 what? Times this is what? 14 plus 3 is 7. So that one would have what? 1750 divided by 2. So that will give us what? 80 what? The 8 carry 1, 7.5 kg. That's what I want to have if you divide it. Let me confirm it with my calculator so I can end this video. So what we have what is 7,000 times 25 divided by what? 200. Okay, 875. So we are going to have 875 as our answer. 875. That will be our final answer. For 875 will be answer. But the question actually that's supposed to write is what? 2,000. If they say 2,000, it will be what? 87.5. I think I wrote a wrong question, but nevertheless, the idea is still the same thing. So if you write 200 is what? 875 kilogram. If you what? Write 2,000, it's 87.5. Thank you very much. See you in my next video.